Okay, so this is about the life cycle of stars. So remember that stars have a beginning, a middle and an end. And we're going to be looking at two types of stars really, a medium-sized star like the Sun and also then massive giant stars. And we also need to understand the idea of gravity, gravity being a force that pulls two objects with mass together. So let's look at the beginnings first of all of stars, and it doesn't matter whether we're talking about normal sized stars or massive stars, they both start with a nebula, and a nebula is just a cloud of gas. That gas is going to be the most simple gas in the universe, hydrogen, and then gravity sort of pulls in that gas a bit, and you then get a protostar. So we haven't yet got a star there, but the gas has been pulled in by gravity, and eventually it will get hot enough and the pressure will build up, so you'll start getting a nuclear reaction as hydrogen atoms will fuse to become helium and give off lots of electromagnetic radiation. And at that point where you've got that fusion reaction happening, it begins to become a star. Now, with a medium-sized star like the Sun, eventually it becomes a red giant, and what will happen is the outer layers will expand, but the inner core actually collapses due to gravity. So then you've got a red giant, and then finally the gravitational pull on the red giant causes that star to collapse, and eventually it will become a white dwarf. And that's a medium-sized star. Now, stars with a bigger mass than the Sun are hotter and they're brighter, and eventually they become red supergiants. And at the end of that period that they're a supergiant, it begins to collapse due to gravity, and then it explodes, and that explosion is called a supernova, and the outer layers of the supergiant are cast off and it expands outwards. Now then eventually what happens is gravity pulls back the remains together, and it will either form a black hole or it will form a neutron star. Black holes are formed at the end of the life cycle of a massive star. They are collapsed stars, therefore they have a very large mass in a very small volume. Tiny volume, large mass, and therefore they have a very high density. The fact that they have a very large mass means that they have a very strong gravitational force of attraction, so strong that even light cannot escape a black hole, so we can't even see them.